hope everybody doing good. So today's session we plan to cover Fabric, Azure Fabric with Data Warehouse. So whatever we have in Data Warehouse concept in Microsoft Fabric, so we plan to see that. Let's have the documentary overview and then we'll do some exercise that gives the people like everybody can understand easily. Getting started with the data warehouse in Microsoft Fabric. So I think in the previous sessions we covered all the topics related to Fabric, mainly like end-to-end analytics and lakehouse in Microsoft Fabric, and then Apache Spark, how to use Apache Spark concept into Fabric side, and then what are all the Delta Lake concept we have in it's in Fabric, and what are all the benefit of Delta Lake concepts. And then we've seen how to build the pipeline, data factory pipeline, to read the data from multiple sources and write the data into one lakehouse or multiple destination places. And another one we've seen like what is the data flow concept, how to use the data flow in Azure Fabric, and using data flow, how to achieve the transformation logic, and what are all the transformation activities are available in Azure Fabric. So these are the concepts we covered. So today mainly we will focus on Azure Data Warehouse concepts, which is supported by Microsoft Fabric. So if after this session you can understand what is Data Warehouse, and if you already have the experience with Azure Synapse Analytics Data Warehouse side, this is nothing, the same concept and the same architecture we are using here. And Data Warehouse concept in any technology, any technologies like either Microsoft or IBM, Netisa, or even Informatica Data Warehouse concept. So the Data Warehouse concept is same everywhere, but the technology will be different, and the methodology to ingest the data, to build the table structures, that will be different. So this session we will see moreover Microsoft Data Warehouse concepts. Let's go to the document. Yeah, data warehouses are analytical store built on relational schema to support SQL queries. Microsoft Fabric enables you to create the relational data warehouse in your workspace and integrate it easily with other elements of your end-to-end analytics solution. So it is nothing but like data warehouse is supporting relational database model. That is nothing but SQL query supporting process model. The data will be stored in relational model. Relational model is nothing but tables, and within the tables you can say like a column and rows, a kind of attributes model. That is a like data warehouse supporting mainly relational schema specific models. Okay, let's start this. Let's see the introduction. Relational data warehouse are the center of most enterprise business intelligence solution. While the specific detail may vary across data warehouse implementation, a common pattern based on the T-normalized multi-dimensional schema has emerged as a standard design for relational data warehouse. Microsoft Fabric Data Warehouse is a modern version of the traditional data warehouse. It centralizes and organizes data from different department systems and the database into a single unified view for analysis and reporting purpose. Fabric Data Warehouse provides full SQL semantic, including the ability to insert, update, delete the data in tables. Fabric Data Warehouse is unique because it's built on the lakehouse, which is stored in Delta format and can be queried using SQL. It is designed for use by the whole data team, not just data engineer. Fabric Data Warehouse experience is designed to address these challenges. Fabric enables data engineer, analyst, and data scientists to work together to create the query data warehouse that is optimized for their specific needs. So what they're trying to say, so relational data warehouse is a center most enterprise business intelligence solution. So that's what just now I told, like data warehouse concepts used by any BI solution. Either it can be a Microsoft BI solution or AWS BI solution or IBM Data Stage and Disha. So those kind of tools, or even if you go for Informatica kind of Informatica tool. So data warehouse concept is a main main model or mm, base for any BI solutions. So business intelligence solution is nothing but uh, we need to build the data warehouse. On top of the data warehouse, you can do your analyst work, or you can do your data engineering work, or you can perform the um, like kind of AI process. So everything, the base is data warehouse. That's what they're saying. So initial days, there was when the relational database started, either is a Microsoft SQL Server or Oracle Server, there is a concept called normalization. So normalization is nothing but we can avoid the duplication, and we can avoid the repeatancy, and then we can build the multiple table in between tables, build the keys like kind of primary key and foreign key, and based on the keys we can maintain the for example, if you can consider, if you are working for any shipping, for example, you can working for cargo domain. So in the cargo domain, there are multiple scenario we can tell, like so one ship will have one booking multiple booking number. So individual booking number will have separate container layer containers information. Inside the container we may have different types, either it's a dangerous container, or it's uh, refrigerator, like a refrigerator container, or it's a normal container. So three types. So these three, like on top of three types, we may have within the container we have multiple items. So that can be separate. So for example, you can take say normal container. In that container you may have some wood item, you may have some oil item, you may have some kind of electronics item. So this is the one structure, one flow. So when, if you want to convert the same flow into SQL Server side, so you should have booking table. So that booking table will have book numbers and then container numbers, or the book number, uh, then another table you need to build on top of that, on the another table you will put container types. That in between container type and booking number, you may have the foreign key primary key relationship, and then you need to put another or the same table you need to put container number, container name, and then container type. And another table, for container you need to maintain another table called items. So in that item table you will have container number, and then individual items, or container primary key, foreign key. That foreign key will be uh, joined with container table, uh, primary key or foreign key, and then container table will join with the booking table. So booking table you have the primary key. So this kind of normalization format you need to build when it's when you want to know when you maintain the transactional data. So when it's coming to the data warehouse concept, that relationship concept, we will be designed with a different way, kind of circuit key concept. But you don't need to build multiple tables and maintain the normalization. So the data warehouse concept will be the T normalization. And then in the data warehouse we have the multi-dimensional model as well. So when you're coming to the multi-dimensional model or dimensional model, there are in dimensional model we have two types. One is not in the dimensional model. In the data warehouse table model, mainly we have dimensional model and then snowflake model. So multi-dimensional model is nothing but you have centralized fact table, and then you have multiple dimension table. That dimension fact table to fact table using circuit key direct relationship will be there, one key to one key, like direct relationship will, the dimension table will direct have the relationship with fact table. This is a dimensional modeling. So that case, going forward we can see the architecture as well. The snowflake model is nothing but one dimension have another subset dimension. So the small dimension or subset of dimension will have the relationship with another dimension. The parent dimension will have the dimension table will have the relationship with fact table. So this is we can call this as data model or multi-dimensional model we can call in we can call in the data warehouse concept. So this is what, like, they are the same concept is supporting in Fabric as well. That's what high level they provided here. Also, the data warehouse will support all the transaction, all the SQL process, like mainly that insert, update, delete, and drop, truncate. So these are all the concept which is supporting in normal data warehouse, the normal database system. Same things will support in data warehouse as well. So, like, let's go to the understand the data warehouse fundamental. The process of building a model data warehouse typically consists of data ingestion, data storage, data processing, data analysis, and delivery. Yeah, data ingestion is nothing but moving data from source system into the data warehouse. For example, you let's take the example, let's say Azure Fabric itself. In Azure Fabric, you have the one lake as a storage, and then you have the data pipeline, or you have the data flow, or you have the data, you have the Spark notebook. So this everything, uh, with the help of this all the tools, you can read the data from your own lake, or you can read the data from any other source, even on-premise system, and write the data into lakehouse, as well as you can write the data into your data warehouse. That is a data ingestion process. And then data storage, storing the data in format optimized for analytics. Yeah, so this data storage with data warehouse is nothing but in that also will store on lake house, one lake, because the backend of Synapse or data warehouse store as a table, but the table will sit on one lake storage level. So you are going to store the data as a fact and dimensions, as a separate table with data warehouse. That is a storage, because when you store the data into when you store the data into data warehouse as a table, you may need to use kind of algorithm. So in the next going forward, we can see what are the algorithm we have, and what are the optimist way we can use to store the data in the as a table. And then another concept, data processing. Data processing nothing but transforming the data into format is ready for consumption by analytical tool. So this is nothing but we will perform the transformation. If you want to, based on our business logic or based on our business requirement, we will build our own transformation logic and then store into again storage. And data analysis and the delivery, analyzing the data to gain insight and delivering those insight to the business. So this is nothing but we can do the data analysis and then do the delivery. That means, for example, you have a data warehouse, and you have some of the data in your data warehouse, some of the data in one lake, using Azure AI engine, or Azure machine learning studio. You are going to read the data from both Synapse, as well as Synapse or data warehouse, as well as from your one lake. Then you are going to perform some analytics, kind of predictive analytics based on the data. After completion of the analytics, what is the output? You can you take that output and store that output into your data warehouse as well. So this kind of data analysis and delivery process also supporting in data warehouse. This is a basic, this is a fundamental of data warehouse concepts. So understand Fabric data warehouse experience. Fabric data warehouse is a relational data warehouse that support full transaction T-SQL capability. You would expect from the you would expect from the enterprise data warehouse. It's fully managed, scalable, and high available data warehouse that can be used to store and query in lakehouse. Using the data lakehouse, you are fully in control of creating table, loading, transforming, and querying data using either the Fabric portal or DSQL command. You can use SQL to query and analyze the data, or use Spark to process the data and create machine learning model. Data warehouse Fabric facilitated collaboration between data engineer and data analytics work together in the same experience. Data engineer build the relational layer on top of the data in the lakehouse, whereas analytic can use T-SQL and Power BI to explore the data. Yeah, so nothing but, so data warehouse is supporting in Azure also same. Um, it will support full DSQL commands, all the DSQL command, Other than that, other than tsql command, you can store the data into lakehouse and data engineer as well as uh, data analytics can work together to build, to develop their BI solution. That's what they are saying. So the same story, like whatever we are, whatever the purpose of data warehouse, they are explaining the same. So that is supporting in Fabric data warehouse as well. Design a data warehouse. Like all relational database, Fabric data warehouse contain a table and store your data analytics later. Mostly these tables are organized in schema that is optimized multi-dimensional model. In this approach, numerical related events group different attributes. For instance, you can analyze total amount paid, sales acquired, specific data. Yeah, it's nothing like the same, again the same explanation. So it is contain the tables to store your data and analytics later. And most commonly this organized schema, like whatever the usually the database means, you need to store your data as a schema, then and up the schema specific, then you can go for the a particular table storage. And then it is supporting multi-dimensional model and snowflake model as well. So if we will, going forward, we can see what is snowflake and dimensional model. So the same thing they are telling, explaining here as well. Table in data warehouse. Table in data warehouse typically organized way that supports efficient and effective analysis for large amount of data. This organization often referred to the dimensional model, which involves structured table into fact table and dimension table. Yeah. So tables. Yeah. In data warehouse, majority of the project, it is required the data will be stored as a fact table and the dimension table. So fact table is nothing but detail level information, and it's like the dimension table is nothing but summary level information. For example, you can consider as a what we call some FMCC product, FMCC selling organization. So when you go for FMCC selling organization, uh, the data will be like you want to build the BI solution for FMCC organization. So the FMCC organization will have the sales in all over the world. Okay, so individual world, sorry, all over the world, they may sell the product via dealership and their own stores, as well as their maybe their own stores and dealership, and then uh, kind of partnership, and via some shopping malls. So maybe shopping mall under some dealership. So you can consider like their own store and dealership and a partnership. So these three concepts they have, three kind of sales mechanism they have. So when you build that BA solution, your fact table will have what is the product, what is the product name, and then what is the store name or what is the store ID, and then that the store is belongs to store ID, and then what is the product that we already covered, product ID, store ID, and then what is the sale amount, and then it belongs to which region, like either country ID or region ID, or yeah, you can consider as a country ID. So these four input and what is a sale date. So these five information, detailed information for one sale. So this will be stored as a fact table. And when it's come to the dimension table, the dimension table will have one dimension table product. So the product dimension table will have product ID and the product name. So what are all the unique product they have in the store, that information everything will be there in the dimension table. For example, the one FMCC company can have more than 200 or more than 500, like it's up to their no capability. So for example, they have 500 unique product, then all the unique product information will be there in your dimension table. And another table, they may have their dealership, like dealership, not dealership, store ID. So that store id will the store id, so store information, so which store, and then which store id, store name, and then it's what type of the store, either it's partnership or their own or dealership. So this information, so these three information will be another table as a what we call uh, seller information. So when you connect with the fact table, you will going to connect with product id to product id with the fact, and the dimension table seller id and seller id with your fact table. So this is way your data warehouse will be like designed. So fact table will have detailed information, and then your dimension table will have the some like summary information or uh, master level information. So using this, you can use circuit key and alternate key join together with fact and dimension, and you can build your like you can do your analysis. For example, you want to see which stores sold more items. So that case, you just join with the fact table and store information table, the dimension table, and you can build your query and you can do your analysis. That's what they are explaining here. Fact table contain the numerical data that you want to analyze. Fact table type a large number of rows are primary source for the data for analysis. For example, fact table might contain total amount paid, sales order that occurs specific date and particular store. Yeah, the same information whatever I explained there just now. So the kind of if you take as a sales as a sales information as a fact table, then it will have sale date, product ID, what is the sale amount, and what date they sell it, and then who sold that. So this all the information will be there, and it's have very huge records, because if you want to maintain 2 year of history in your fact table, then what are all the days, what are the product, and who are all the uh, vendors or who are all the salespersons sold those on information, that detail level information will be there. And the dimension table contains descriptive information about the data in the fact table. So dimension table have the small number of rows. Yeah, that's what. So one company, like say one FMCG company has have 500 unique product, only 500 rows will be here. There won't be any new product is coming, then it's going to be added in the dimension table. So this is the dimension table have very less data comparatively fact table, because fact table will have entire transaction data with numeric format, because in that fact table we are not going to maintain the data as it is. We are going to build, we will create the circuit key, and kind of the circuit key will be integer format to join the dimension table. That case will be very efficient. So this is a normal data warehouse concept. So we need to, the same things is supporting here as well. So a circuit key is a unique identifier for each row in the dimension table. It's often an integer value. The value automatically generated by the data management system when new rows inserted into the table. Okay. An alternate key is often natural, and business key identifies specific instance for entity interaction source system, such as product code, customer ID. Yeah. So this is nothing but so circuit key is yeah, mainly in the data warehouse concept we are using circuit key and alternate key. So circuit key is nothing but auto incremental key when you build the table in dimension. So it will whenever you in the dimension table, mostly dimension table will have auto identity key. So any new rows in setting, the auto identity key will be it will get increased. So same things we will, because the this will be integer, the same auto identity key will be insert into fact table as well. So that case it will be useful for joining as well as any analysis. So some rare case scenarios we will use alternate key. For example, if your table, like your dimension table, like product table or customer table does not have the identity key, then you can use product code and customer ID as a primary key, or like a foreign key that will be joined with primary key here in the dimension table. That same product code and customer ID will be available in fact table. So that will be your foreign key. So that case we can use as a alternate key as well to to join the tables or to do any analysis with the database. So you need both circuit key and alternate keys in data warehouse, because they serve different purpose. Circuit key is specific to the data warehouse, and help to maintain consistency and accuracy in the data. Alternative keys, on the other hand, specific source system help maintain between the data. So yeah, that's what. So in dimension table, you will have auto identity key, and then you will have your product key, or what we call your customer ID, because that surely will needed in reporting purpose or analysis purpose. That's what they are highlighting. So in DataWarehouse, we have both alternate key as well as all the what we call surrogate key as well. Special type of dimension table. Yeah, special type of dimension table provides a context enable more comprehensive data. Time dimension provide the time period which event occurred. This table enable the number of, for example, dimension table might include a column of the year, quarter, month, day. Slowly changing dimension or dimensions that track the change dimension over time, like changes to customer address, product price. The significant rows because they enable user to analyze understanding the changes to over it, and slowly changing dimension ensure the data stay up to date and accurate, which is important to make to business decision. Yeah, so there are special type of dimensions we are using. So nothing but when you build your data warehouse concept, you will have the product information as a separate table. You may have your customer information as a separate table. You may have your seller information as a separate table, but you may not have your time dimension table. So in data warehouse concept, in data warehouse itself, time dimension table will be available. So we can utilize that for our purpose. So that table we will build as a normal date, and then particular year, quarter, and then month number, quarter number, and year number. So this kind of all the attribute we will create, because this everything will be useful for your analysis purpose as well as in the Power BI report purpose. So that's what a special dimension. And then slowly changing dimensions, it's nothing but we can build for incremental purpose. For example, you have 100 product, so 100 product is in your dimension table. Like going for in the future, you are going to get more than 100, like for example 200 product. So out of, you need to compare both your existing table and new table, new dimension information. So whatever it's already exist, you need to ignore that. Whatever not exist, you need to insert only latest product. For example, one particular product ID will be available. uh, for example, how to tell that? So when we will use slowly dimensions, two cases: either you can maintain the incremental data, or if you want to change existing data information. For example, you have one product. Last month you called that product ID, product number, and then product name is soap. Okay, so last month in your company have one product. That product ID is product ID name was soap, and then this month the same product ID your organization decide to change it to instead of soap, detergent. So your dimension table should reflect the latest name, not the old name. So this kind of scenario, if you build the slowly changing dimensions, what will do? It will compare your product ID to product ID, and then it will verify what is the old name and what is the new name, and then what is the new name is there. Then that new name will be get updated in your dimension table. So this kind of slowly changing dimension concept also we can able to perform in we can able to create in data warehouse. That's what they are trying to explain here. Data warehouse schema structure. Yeah. So this is schema design. So we have uh, like two type. One is like star schema, and then another one is snowflake schema. Okay. Makes sense. Yeah, snowflake schema. So star schema, you can see in this image, we have the fact table and we have multiple dimension table. This dimension have direct relationship with the fact table with the circuit key or alternative keys. That is called star schema. And dimensional modeling, yeah. And then another model is another schema is snowflake schema. So your fact table here, your some dimension direct have the direct relationship with the fact table, and some dimensions have the relationship with the direct relationship with another dimension. So this is subset like the small dimension, this is a bigger dimension, or this is a master dimension, and these are all subset dimensions. So that case it will have the relationship with the main master dimension, and that master dimension will have the relationship direct relationship with fact table. That's what Snowflake schema. Understand data was in Fabric. Fabric data was also a files folder labels or release. Okay. Fabric Legos is a collection of files, folder, tables, and shortcuts that act like a database over a data lake. It's used by the Spark engine and the SQL engine for big data processing, and has feature for ACID transaction, which using the open source delta format tables. The Lakehouse is a great place to store data, but it's not the best place to serve data to business user. For that, you need a data warehouse. Fabric data warehouse experience allow you to transition from the lake view of one lake supported engine Apache to the SQL experiment traditional data warehouse. So to provide the lakehouse give you the ability to treat tables, use a SQL analytics endpoint, whereas the data warehouse enable you to manipulate the data. In the data warehouse experience, you will model data using tables and views, run T-SQL query data across the data warehouse and the lakehouse. Use T-SQL to perform DML operation on the data inside the data warehouse and serve reporting layer like Power BI. Now that you understand the basic architecture principle of relationship data warehouse schema, let's explore the great new data warehouse. Okay, so in my previous sessions, like in the, I think the first session or second session, I'm not sure. So we've seen, so whenever in the one lake, you can store the data as a lake house or as a file level, as a folder level. Then you can insert as a table. You can insert it to the table. So the table also will create in one lake. So you can able to use both lake house analytics, like you can read that you can read the data as a folder or file, and then you can able to use you can able to read the data as a table also. So you don't need to build any separate semantic layer. You just to enable, you can just to turn to the SQL model or enable that semantic model. The table will be used convert as a semantic model. You can directly use into your Power BI. So the only drawback is, so that will, so already the feature is available. So people may come to the questions asking, like they may ask, already storing is a table and storing is a file, that is automatically converting to the semantic model, then why I need to use a data warehouse? So those things, what will happen, once you insert the table, you can able to use as a semantic model, and you can for BI or any reporting, but you can able to read the data, but you cannot manipulate the data whatever you store as a table. So if you want to manipulate the data, for example, if you want to you after store the data into our fact table dimension table, you want to delete some records, or you want to update some records, or if you want to do kind of like individual any slowly changing concept, or if you want to perform any truncate or drop any manipulations. So that case, you cannot directly do use you cannot directly perform in semantic matter. So to do that, we need to build data warehouse concepts. That's what they are trying to say in no, they are trying to explain the Fabric in this session. To describe the data warehouse in Fabric, in the data warehouse experience Fabric, you can build the relational layer. So that's what, like you can, when you go to our workspace, the workspace level, you can build the data warehouse. Then the data warehouse level, you can build the table. So if you see here, so what we are doing, copy into this particular table from this location file with the file type and the credential. We are sharing secret code, and yeah, this is a syntax to create the table in Azure Fabric data warehouse. And then you can read that query, read the data from that table. table consideration. After creating the table in DataWarehouse, it's important to consider the process of loading into those tables. A common approach is to use staging table. In Fabric, you can use tsql command to load the data from file into staging table in the DataWarehouse. Staging table are temporary table that can be used to perform data cleansing, data transformation, data validation. You can also use staging table to load the data from multiple sources into a single destination table. Usage data loading is performed with periodic batches process in which insert and update to the data rows are coordinated to occur at the regular interval. For example, daily, weekly, monthly. Okay. Generally, you should implement data rows load process that performs task in following order. Insert a new data to be loaded into the lakehouse. Applying preload cleansing or transformations are required. Load the data from files into staging tables in the relational data rows. Load the dimension tables from the dimension data and changing layer, updating existing rows or inserting new rows, generate key values are necessary. Load the fact table from the fact data in the staging table, looking up appropriate circuit key for related dimension. Perform post-load optimization by uploading indexes and table and distribution statistics. Yeah, so this is what like the what they are. So whatever we will do in data warehouse, any data warehouse, the same things they are explaining here. First, we need to load the data. So we can, for example, uh, like make the like we need to load the data, and then after before loading the data, we need to do the pre-cleansing and transformation if required. So that means like you will create the staging table, then you will compare that you will join the staging table with the dimension table, and you will retrieve the time from the dimension table. You will retrieve the dimension key or circuit key, and then finally you will insert that data into your fact table. Okay, so then when you load the data to dimension table, you will perform the incremental process that also they are mentioning. And then when you load the data to fact table, the staging table is one of the like intermediate table which will be useful to verify the current data is already exist in the fact table, and what's the change we need to based on the existing data availability. It will finalize like we need to like we will finalize it will we need to update the data or insert the data or no delete the data. And then after loading the data into fact table, so we will consider our optimization concept. Either you can create proper index for the table, and then distribution algorithm, which what kind of distribution algorithm we need to use, and then if you want we need to refresh the statistics, and then we will create proper partition for the fact table. So this all those performance process also, like a performance optimization process also we need to follow. Okay, next, query and transform the data. So now we know like how to create the table, and once we build the table, what kind of optimization we need to perform, and then you can use the you can query the data as well now. So here in this query, what they are mentioned, they are creating the view, and that view they are joining with the fact and dimension. Whatever their final output they need, they will create as a view. So we can query the view and verify the data. So most probably this particular finalized view, like we will use into Power BI report. So whatever the business like we need to write, and what are the dimension table and fact table we need to join, we will join those, and then insert insert into create as a view. Then this view can be used into your Power BI report or any report. So query data using Visual Query Editor. Yeah, I think this we already seen Power Query online diagram view. We it's supporting in our Fabric warehouse. So you can go here and drag and drop the tables and join those tables whatever we want. And if you want to do any transformation, we can perform. This also supporting in DataWarehouse. So prepare data for analysis and reporting. Yeah, let's go next. A semantic model defines the relationship between the different tables in the semantic model, the rules for how data is aggregated and summarized, and the calculation or measure that used to derive insight from the data. These relationship and measures are included in the semantic model, which is then used to create reports in Power BI. You can easily switch between the data query and model view fabric using the menu in the bottom of left corner of the screen. The data view shows the table in the semantic model. The query view shows the SQL query that are used to create a semantic model, and a model shows a semantic model. Build a relationship. Yeah. Once your table got created, then you are going to create the model view. The model view, you are going to create the time relationship between the tables. So what are the, if you see customer key to customer key, we are creating a join relationship, and then here most probably date key to date key will be here, and then here we have the product alternate key or product key. Using this, we will create the product key to product key relationship. So this like this relationship will be we need to create, and then it will create as a semantic model. And then we need to create the measure as well. So measure is the kind of sum of sale amount and count of sale items. So this kind of measures we need to create in the semantic model. And if you feel like in the reporting perspective you are not going to display any specific attribute, then you can, if there is option to hide those field as well. So in the model level, in the data warehouse level, this field will be there, but when it coming to the reporting level, this field will be disappear. So you can hide that unnecessary field as well. And then understand semantic model. Every time DataWarehouse is created, Fabric create a semantic model for any analysis and business user to connect for reporting. Semantic model has metrics that are used to create reports. Simply put, unless you semantic model, you create your warehouse, which is stored in a semantic model. If you are familiar with Power BI working with a semantic model, create the data warehouse experience will be straightforward. Semantic model are automatically kept in sync with the data warehouse, so you don't worry about the maintaining them. You can create the custom semantic model to meet your specific needs. Yeah, so that's what in Fabric. If you created a table, and then you can just connect automatically, the semantic model it will get create. Even whatever you are inserting the data into your data warehouse, automatically it will sync to your semantic model. So you just use the semantic model tables to your Power BI report or any report. So that case, you don't need to worry about the conversion. If you want to specify any particular semantic model, if you are building, then you need to mention the specific reference model. Understand this default understand the default semantic model. There is also default semantic model automatically created for you in Fabric. It inherits the business logic from the parent lakehouse or warehouse, which is initiate the downstream analytics experience for business intelligence and analysis. The semantic model is managed, optimized, and kept in sync for you. New tables in warehouse automatically added to the default semantic model. User can also manually select the table or view warehouse they want to include the model for more flexibility. Objects that are in the default semantic model are created as a layout in the model view. Yeah, the same. So whenever you are adding any table to Azure Fabric, it will default convert to a semantic model. If you want to remove any specific table from the semantic model, you can remove it. Or if you want to specify any specific table to semantic model, you can specify that as well. So visualize data. Yeah, so when you initialize so you can use this your data or semantic model to Power BI, and then you can visualize whatever you want. Like you can build your chart like a bar chart, line chart, or pie chart, even table or matrix, anything you can create. That's what they're saying. Secure and monitor data warehouse. Yeah, let's go. What kind of security we have? Security and monitoring critical aspect of managing your data warehouse. Okay. Data warehouse security is important to protect your data from unauthorized users access. Fabric provides a number of security features to help you secure data warehouse. These include role-based access airbag to control the warehouse as it is. SSL encryption to secure communication between the warehouse and the client application. Azure Storage Service encryption to protect the data and transistor to rest. Azure Monitor, Azure Log Analytics to monitor the warehouse activity and add that to the data. Multi-factor authentication, we add the extra layer for security to user account. Microsoft Entra ID interaction to manage the user identities and access to the warehouse. Yeah. So in data warehouse, whatever the security process we have in Azure, same things is available in Fabric as well. Azure Fabric as well. So mainly the role-based access. So this is nothing but role-based or role-based access. Particular if the reader is if you mention particular person is a reader, then they can able to read the data. They cannot manipulate any data. And if they want to see any particular row kind of any, for example, you have the multiple department information in your table. So individual department wise, whoever the part of the department, those people can see only that related to their department data. So that kind of method, that kind of security process also we can do. And SSL encryption, so this is via default supporting by Azure. So and then Azure storage level information, like automatically it's Azure storage service encryption to protect transit at risk. So that these are the securities maintained by uh, Microsoft. So same thing supporting here. And then you can using Azure Log Analytics, you can monitor your data. So any data changes or any data corruption or any data deletion, so you can using Log Analytics, you can build your alert as well. So that case you can act quickly. And anyhow, multi-factor authentication also supporting. And other than that, Microsoft Android integration to manage user identity and access a warehouse. Yeah. So to access the warehouse, you can maintain, you can give the particular user access. So user specific maintenance access also we can able to maintain. So these are the security process available. So it is more secure, and whatever we have in Azure Synapse Analytics, same security is available here as well. Workspace permission, yeah. So as we know, like this is working as a workspace my model. If you look for Azure previous service, traditional Azure services, like we need to go with subscription. Under the subscription, we need to go with the resource group. On top of the resource group, you will have particular resources. So here is nothing but everything combined with workspace only. So data and Fabric is organized into workspace, which is used to control access, manage life cycle of data and services. Appropriate workspace roles are the first line of defense in security or data warehouse. In addition to the workspace role, you can grant item permission and access through SQL. Yeah. So whatever using the SQL mechanism, we can follow the same to provide the access. Yeah, read item permissions. Either you can read data, read all, or particular row based security or algorithm security process we can keep. Monitoring activities in data is crucial in optimal efficient utilization. Identify the issues, detect anomalies, and take action to keep the data running smoothly and security. You can use dynamic management views to monitor connector session and request status to see live SQL queries, life cycle inside with GMS. You can get the detail. Yeah, so we can use TM view to see the dynamic management view to see the to monitor the connection sessions, and even SSMS level you can see that. Even you can put the query and see that whatever we are doing in SQL Server, say all the query, all the monitoring process we can able to do here. And if you want to, you can see what are the session is active, what are the session is a long time is running. So if you want to kill any particular session, that option also available. List data in data warehouse. Yeah, this is here we are coming to the exercise. I think it's almost 48 minutes. So I think I will cover this exercise as a separate session, and then I will merge those and publish it. So in the next session we will see the exercise for data warehouse. Let's see how it will go. Thank you everyone.